All right, today's lesson is vertical and adjacent angles. So as we just did in the warm-up yesterday, we talked about complementary and supplementary angles. We also looked at an angle yesterday, and I told you that it was a vertical angle, but we didn't talk much about it. So we'll be talking about what those are. And just like we did yesterday, we'll be finding missing angle measures, this time using vertical and adjacent angles. This is the last new lesson that will be presented this week. The remainder of the week will be spent in activities practicing finding these angle measures. So I know the Get More Math was difficult for you guys yesterday, but because we'll be practicing this over the next couple of days, it should be pretty comfortable by the end of the week. All right, first is vertical angles. Vertical angles are opposite each other when two lines intersect. So angles 1 and 3 would be vertical angles because they're across from each other when two lines intersect. So angles 1 and angle 3 are vertical angles. And then the other set of vertical angles is angles 2 and 4. That's supposed to be a little and sign. It's kind of hard to see. Angles 1 and 3 and 2 and 4. Now, vertical angles are always equal. And here's why this is true. I'm just going to make up a value. Say angle 2 was 80 degrees. If angle 2 was 80 degrees, then what would angle 1 have to be? Irene? 100, because angle 2 and angle 1 would form a supplementary pair of angles because together they form a straight line. So this would have to be 100. Angles 2 and 3 also form a straight line off of this line, so what does angle 3 have to be? 100. So therefore, vertical angles are always equal. If angle 1 and 3 are 100, angle 2 is 80, what does angle 4 have to be? 80. Good. Okay, the other kind of angles are adjacent angles. Adjacent angles have a common side, a common vertex, and they do not overlap. If they form a straight line, they are supplementary. So adjacent angles really aren't a new kind of angle. They're just kind of another way. You can have adjacent angles that are not supplementary, but all supplementary angles are adjacent. So angles 1 and 2, they share a common side. This is the common side that they share. They don't overlap. They share a common vertex. So angles 1 and angle 2 are adjacent angles, and they are also supplementary. Angles 3 and 4 also share a common side. So angles 3 and 4 are adjacent. There are actually some more adjacent angles up there. Does anyone see another pair of adjacent angles? Violet?
2 and 3.
2 and 3. Angles 2 and 3 share this common side. There's one more pair. Adria?
1 and 4.
1 and 4. 1 and 4 share this common side. So angles 1 and angle 4. All right, any questions about these definitions before we move on? Okay, this asks us to name all of the vertical angles and adjacent angles. There are actually 1, 2, 3, 4. There are 8 vertical angles and 16 adjacent angles. So we're not actually going to name all of them. We're going to name some of them. So let's start a list first of vertical angles. And I'm going to call on some of you to give me some vertical angles. Riley, tell me one pair of vertical angles. Well, 1's over here, 6 is over here. Vertical angles need to actually share a common vertex. So here's the vertex for angle 1. Which angle that's across from angle 1 shares the same vertex? 2 shares a common side with angle 1. Vertical angles do not share the common side. It's like you start at the angle, you hop across the vertex, and it's the angle you end up at. That's a vertical angle. So if I start here, end up here, what angle is that? Angle 4. So angles 1 and angle 4 is one pair of vertical angles. McKenna, what's another pair of vertical angles?
Angles 2 and 3.
2 and 3, yes, 2 and 3 in that same circular section there, angles 2 and 3. Jimmy, what's another pair of vertical angles? No, 5 and 6 share a side, so they're not vertical. Vertical angles share a vertex, but not a side. Brayden, can you help him out? No? Okay, guys, I think you're still a little bit confused about this definition. Look, vertical angles share a vertex, but not a side. Adjacent angles share a vertex and a side. Okay, so Jimmy, if we look at angle 5, do you see angle 5 on your paper? Okay, which angle shares the same vertex but not the same side? 7, good. So angle 5 and angle 7 are vertical angles. Brayden, take a look at angle 9 right here. Which angle shares a vertex but not a side with angle 9? 11. So angle 9 and angle 11. Let's keep going with this. Eve, give me another set of vertical angles.
12 and 10.
12 and 10, good. Okay, we'll do one more set if this goes well. Elena?
Angles 14 and 15.
14 and 15, good. Okay, are you guys all clear now on vertical? Okay, let's do adjacent. Let's use a different color for adjacent. Okay, so adjacent angles, just a reminder, are angles, they also share a vertex and they share a side. Ailey, what's a pair of adjacent angles? 1 and 2. 1 and 2. As we said, there are 16 of these, so we'll do about 6 maybe. Reagan, another pair of adjacent angles.
5 and 6.
5 and 6, good. Ross, another pair.
7 and 8.
Yep. Sky, another pair.
9 and 10.
Good. Kaylin, another pair. 12 and 11, good. And let's do one more pair. Adria?
3 and 4.
Good. Okay, once we cleared that up about vertical angles, adjacent angles seem to go a lot better, so that's a good thing. Okay, let's take a look now at the example. Find the value of x and the measure of angles 1, 3, and 4. So we know the angle of 2. We're going to find the measures of all of the other angles. Michaela, what equation could I write to find x?
180 equals 75 plus 3x plus 15 in parentheses.
Good. So how would we describe angles 1 and 2? There are 2 words we could use to describe them. Any volunteers? One that we learned yesterday and one that we learned today. Violet?
Vertical?
No, they're not vertical.
No, adjacent.
Adjacent. Angles 1 and 2 are adjacent, and they are also what? Eli? Supplementary. So they are adjacent and they are supplementary. So Michaela's given us this equation Taryn, what would I do first to solve that equation?
You would add 75 and 15.
Good, good. We want to simplify this side first. We're going to add 75 and 15, which would give us 90 plus 3x. Okay, then subtracting 90 from both sides gives us 90 equals 3x. Dividing both sides by 3 gives us x equals 30. You'll notice as I'm solving these two-step equations, I'm not showing all my work in the sense of writing the minus 90 underneath or the divided by 3. I'm telling you what I did, and then I'm showing the next step. If you are really comfortable with two-step equations, which I think most of you are, you can move on to this level of showing your work. But I would encourage you to continue to write them minus whatever you're subtracting. Show your division if that's helpful to you. All right, so x equals 30. It asks us to find the value of x, so we found that. X is 30. Also the measure of angle 1. What would the measure of angle 1 be? Pat?
It would be It would be 105.
105, good. Tell me how you got 105.
Well, I did 180 minus 75.
Okay, and that's one way you can do it. You can just, you don't even need the 3x plus 15 because angle 1 forms a supplementary angle pair with angle 2, so you can just subtract 75 from 180. Did anyone do it a different way? Anyone use the equation? Carly?
I did plug 30 in for x.
Okay, good. So you could also plug the 30 in for x. 3 times 30 is 90, plus 15 is 105. Brayden, if angle 2 is 75 and angle 1 is 105, what would angle 4 be? What would angle 4 be? Number 1 is 105 degrees. 2 is 75 degrees. What would angle 4 be? 75. And judging from the pause you gave before you gave me that answer, did you subtract this from 180 to get this? What else could he have done? Violet? Yeah, vertical angles are equal. So you can also just say, oh, if 2 is 75, so is 4. Katie, what would angle 3 be?
105.
It would be 105. How did you know that so quickly?
Because it's equal to 1.
Good. Good. Because it's equal to angle 1. All right, the next slide is a practice for you to do. So I want you to take a couple minutes and work on this, and then we will be going over it. All right. Jake, give me one pair of vertical angles from this.
5 and 7.
Okay, 5, angle 5, and angle 7. Good. Give me another pair, Devin.
Angle 2 and angle 4.
Good. Angle 2 and angle 4, and give me one more pair, Grace.
Angle 1 and angle 3.
Good. Okay, now 4 sets of adjacent angles. Carly, give me one.
Angle 1 and 4.
Good. Irene, another one.
And then angle 6 and angle 5.
Good. Reed, another one.
Angle 2 and 3.
Good. You had to check to make sure the one you were going to say wasn't up there, huh? And the last set, Violet.
78.
Good. Name one set of supplementary angles. Eli.
Angle 1 and angle 2.
Good. You could have used any of the angles that you used above as adjacent angles for number 3. Number 4, if angle 4 is 45 degrees, Dakota, what's the measure of angle 1? You gonna do that one? Ailey? 135. So angle 1 would be supplementary with angle 4, so angle 1 would be 135 degrees. Riley, what would angle 2 be? 45. Good. And what would angle 3 be? McKenna?
It would be 135.
135 again. Good. Just out of curiosity, if we were to add all of these angles together, angles 1, 2, 3, and 4, what would we get? Katie? 360. There are 360 degrees in a complete revolution, so in a circle, so we would get 360 degrees. Also, you can think there's 2 straight line halves, each of which is 180, and 180 plus 180 is 360. All right, today we are going to do an exit ticket. I'm going to show it on the screen, and I actually put it on paper for you because I know it's kind of hard sometimes to read from far away. It's a little easier since it's cloudy today and it's not very bright. So I have some little half sheets for you. So I think I'll not put it on the screen at all. I'll just pass out these sheets, and you can do the exit ticket. And then I will also pass out today's homework assignment, which is brief, that you can get started on as well. And then we'll actually be doing a scavenger hunt activity during the lab class today. So that'll be kind of fun.